Hello, Hello, Art and Warriors. Today, we're going to solve 2023 AP Statistics free response question number 6. We need to find the population distribution and the area, the probability that the amount of gold applied to the necklace is between 296 milligrams and 304 milligrams. So what do you have to do? It's already known the mean and the standard deviation. So this follows the normal distribution of mean 300 and the standard deviation of 5. Let's first get the z-score of 304. So the z-score of 304 is 304 minus mu, the mean, over the standard deviation 5, which gives us 0.8. And the z-score so this is for 304, and the z-score for 296 minus mu over standard deviation is negative 0.8. Okay, so if there is a normal distribution with mu 300, we are getting the probability that the weight is in between these two. So we need to find the probability that the z-score is in between 0.8 and 0.8. So how do we find that? We just have to find the value, the probability, we're using the table, right? So if we actually look at the table, this is 0.7881 minus 0.2119. So the area, the probability that the weight would be in between this here would be 0.5762. Okay, all right. The next question asks to suppose the machine is properly working the mean amount of gold being applied, 300 milligrams, and a deviation of 5. This is same, but we have to calculate the probability that the sample mean amount of gold applied to a random sample of n equals 2 necklace will be greater than 303. So in this case, we just have to do the z-score again. So our sample here is 303 divided by mu, but this time we have a sample of n minus 2. How do we get the standard deviation here? We just have to divide by square root of 2. So this is our standard deviation now. So our new standard deviation here. So if you calculate this, you will get 0.85. Okay. So what is the overall area? The probability that the z-score would less than 0.85 is actually 1 minus 0.023. So the area overall is 0.8023, which is 0.1977. All right. And says suppose Cleo took the random sample of n equals 2. So he takes two samples, necklace that resulted in a sample mean amount of gold applied 303 milligrams. Okay. And would that result indicate the population mean amount of gold being applied by the machine is different from 300 milligrams? I would say, so assume the machine is working properly. If the machine works properly, which means that it will have a consistent mean mu of 300 milligrams, there is a 0.1977 that we got from here, probability multiplied by 2, right? Since this n is equal to 2. So there is if you calculate this is 0.3954 probability of getting a sample mean of 303. So the probability of getting the weight equals 303 is actually 0.3954. So by sample mean or more extreme in either direction, purely by chance. So since this is greater than 0.005, we do not have a convincing evidence that the mean of gold is different from 300 milligrams. Okay, so this 0.05 is just a significant alpha that we normally use. So I would say no here because this probability is significantly higher than 0.05. So this is not just a random chance. Okay. All right. The next question, we are given three graphs with different standard deviations. And it says describe the sampling distribution of the sample range for random samples size n equals 2 from a normal distribution with the standard deviation equals 5. So as shown in graph 1. So the distribution of the sample range from a random samples of the size n equals 2 here, a normal distribution amount of gold with standard deviation of 5 is skewed to the right. So if you look at here, this is skewed to the right. With a median, standard deviation equals 5, skewed to the right, and the median between 4.5, 4 or 5 milligrams, a range about 220, 28, right, milligrams, and no obvious outliers. So there's no obvious outliers, but we can notice that the range, it has about 28 milligrams and no outliers. And the next question asks that describe how the sampling distribution of a sample range for samples n equals 2 changes as the value of population standard deviation increases. Okay, so what can we say this? Let's look at the graph again. So we notice that as the population standard deviation increases, the graphs become more and more skewed to the right. And the medians and ranges increase. So here it has a ranges about 28. Now it's over 30. Now it's over 40. So you can describe that in here. And the last question says that consider Cleo's range of 10 milligrams from the size of the sample size n equals 2 if the machine is working properly, which means spitting out the equal mu, 300, properly with a standard deviation of 5 milligrams. Is a sample range of 10 milligram unusual or not? Okay, so let's get the probability that the sample range is greater than or equal to 10. How do we get this? We can add everything, the probability from all the samples. Add every number. So 0.04 plus 0.03 plus 0.02 plus 0.02, 02 again, and then 3 01s, and then 2 0.005s, which gives us about 0.17. Okay, so assuming that the machine is working properly, there is about 0.17 probability of getting a sample range of 10 or higher purely by chance. So since this is greater than 0.05, which is our common threshold for the probability, we can say that this is not unusual. So we can conclude that it's pretty usual to have a sample range of 10 milligrams. Okay, and the last question asks, do Cleo's sample mean of 303 milligrams in the range of 10 milligrams indicate the machine is not working properly? Okay, so let's find the probability that the average, sample average, X bar, is greater than 303 or sample mean less than 297, given that the mu is 300. So what is this probability? You can actually get the z-score that we did here, and then read the table, and all you have to do is just subtract it. So if you actually calculate this, you would actually get 3954. Okay, and we need another probability, the probability that the sample range is greater than or equal to 10, given that the standard deviation is 5. So we already got this where this is 0.17 based on this graph right here. Okay, and okay, so the very last thing, the probability that we ultimately want to get is that the probability that combines these two, right? So the probability that these two happening at the same time, you always have to multiply these two probabilities. Okay, so you can multiply these two probabilities, 0.17, which gives us about 0.067. Okay, so assuming the machine are working properly, where normal distribution with mean 300 and standard deviation of 5, there is a 0.107 probability of getting Cleo's result, or more extremely purely by chance, because this is obviously greater than 0.05. So we do not have convincing evidence that the machine is not working properly, which means the machine is working properly. Okay, hope this video was helpful. And if you have any questions, please leave them in the comment, and I'll see you in the next video. Thank you.